Welcome to part 3. In this final lesson on the characteristics of science, we will explore objectivity, the methodical nature of science, how knowledge builds over time, the importance of replication, and how scientists make predictions. These characteristics complete our understanding of what makes science work. Let us finish strong. Objectivity or objective means removing personal bias from science. Science should be based on evidence, not on what we believe or prefer. For example, if I measure plant height with a ruler, I get an objective measurement. Whether I like plants or not doesn't change the measurement. Whether I'm from Ghana or Japan doesn't change the measurement. The measurement is the same. But if I just say the plant looks big, that is subjective. It depends on my personal opinion. What looks big to me might look small to someone else. Science aims to be objective. Scientists use standardized methods and measurements so that anyone, anywhere, can verify the results. This is why science is universal. A scientific discovery in one country can be verified in another country. Scientists from different cultures and backgrounds can agree on scientific facts because they are based on objective evidence, not personal opinion. This is one of the most powerful aspects of science. It transcends cultural and personal differences. Methodical means following a systematic step by step approach. Scientists don't just randomly do things and hope for results. They follow clear procedures. They document each step. They record what they do and what happens. This is important for several reasons. First, it ensures that the investigation is systematic and thorough. Second, it allows other scientists to follow the same steps and verify the results. Third, if something goes wrong, the documentation helps identify where the problem occurred. For example, if I'm testing whether fertilizer helps plants grow, I would follow a methodical procedure. That is, prepare the soil, plant the seeds, apply fertilizer to some plants, but not others. Water plants equally, measure growth at regular intervals, record all observations, and then analyze the results. By following this methodical approach, I ensure that my investigation is thorough and that others can repeat it. Methodical procedures are essential for science because they ensure consistency and allow verification. Science is cumulative. That means Knowledge builds up over time. Scientists don't start from scratch. They build on what previous scientists have discovered. For example, our understanding of atoms didn't happen overnight. It took centuries. Ancient Greece theorized about atoms. In the 1800s, scientists discovered electrons. In the 1900s, they discovered the nucleus. Throughout the 20th century, they discovered protons, neutrons, quarks, and other particles. Each discovery builds on previous discoveries. The same is true for medicine. Doctors today know so much more than doctors 100 years ago because medical knowledge has accumulated. Each study, each discovery, each innovation add to our understanding. Technology works the same way. The smartphone you might have is built on decades of discoveries in physics, chemistry, material science, and engineering. Each innovation builds on previous innovations. This cumulative nature of science means that scientific progress is continuous. We are always building on what we know to discover new things. This is why science is so powerful. It is a collective effort across time and across the world. Replication. Replication means repeating an experiment multiple times. Why is this important? Well, sometimes you might get a result by chance. For example, if you flip a coin once, you might get heads. But that doesn't mean the coin always lands on heads. You need to flip it multiple times to see the pattern. The same is true for experiment. If you do an experiment once and get a result, you can't be sure that result is real. You need to repeat it. If you get the same result the second time, that is more convincing. If you get the same result the third time, even more convincing. By repeating experiments, scientists ensure that results are real and not just due to chance. If results vary greatly between trials, that tells scientists something is wrong. Maybe the procedure wasn't followed correctly. Maybe there is a variable they didn't control. Replication helps identify these problems. This is why scientists often repeat experiments many times. They want to be confident that their results are real and reliable. The final characteristic is prediction. Scientists use patterns they have observed to predict what will happen in the future. For example, weather forecasters observe weather patterns and predict rain. Seismologists observe earthquake patterns and predict where earthquakes might occur. Doctors observe symptoms and predict health problems. Predictions are powerful because They test scientific knowledge. If a scientist predicts something will happen and it does, that confirms the understanding. If it doesn't happen, that tells them the understanding needs revision. Predictions also help us prepare for the future. If scientists predict a hurricane, we can prepare. If they predict a disease outbreak, we can take precautions. So, prediction is both a way to test science and a way to solve real world problems. When scientists can make accurate predictions, it shows their understanding of the world is sound. Let's review all 14 characteristics of science. Reproducibility ensures results can be repeated. Observation is where science begins. Empirical evidence means we use measurements, not opinions. Precision means consistent, detailed measurement. Accuracy means correct measurements. Validity means experiments test what they are supposed to test. Consistency means findings are reliable over time. Tentative means science is open to new discoveries. Verifiability means claims can be tested. Objectivity means we remove personal bias. Methodical means we follow systematic procedures. Cumulative means knowledge builds over time. Replication means we repeat experiments. And prediction means we use patterns to anticipate outcomes. Together, these 14 characteristics make science trustworthy, reliable, and powerful. These characteristics do not work in isolation, they work together in a system. So, observation leads to questions, questions lead to hypotheses, hypotheses are tested through methodical objective experiments. Results are empirical, precise, and accurate. Results are replicated to ensure consistency. Findings are verifiable and valid. Knowledge accumulates over time. Science remains tentative and open to new discoveries, and scientists use patterns to make predictions. This is interconnected system. This interconnected system is what makes science so powerful and trustworthy. Each characteristic supports and reinforces the others. Together, they create a system that produces reliable, trustworthy knowledge about the natural world. The 14 characteristics of science are the foundation of scientific thinking. They ensure that science is reliable, trustworthy, and powerful. By understanding these characteristics, you are learning to think like a scientist. You are learning to observe carefully, test ideas systematically, and draw conclusions based on evidence. These skills will serve you well whether you become a scientist or not. In any field, these careful observation, systematic testing, evidence based reasoning are valuable. So, As you move forward, remember these 14 characteristics. They are the foundation of science. Thank you for watching all three parts of the 14 characteristics of science. If you enjoyed this lesson, please like and subscribe. In our next lesson, we will conduct practical experiments that demonstrate these characteristics. We will do three hands-on experiments that show how science works in practice. See you then.